Hello, in this tutorials we will learn how to model and analyze and design an isolated footing. So the dead load is 750 kN, the live load 600, columns dimension 750 300 mm, F'C 30 megapascal and Fy 420 megapascal, and the bearing capacity is 180. So let's get started. Open the safe, create a new project. The design code ACI 31814, units metric default, and click OK and click blank. You can hide the horizon by click on set display options, click and OK. So firstly define materials and click on CSA C30, modify, we'll choose C30, weight per unit volume is 25, modulus of elasticity of C30 is 29440, and F'C is 30 megapascal. Okay, and click OK. Now we click on rebar, modify T420 78.5 and 1.25 times 420. Click OK and OK. Now I will draw the point. So click draw points and click on 0, 0. Escape and click modify. I will assign the load, so select this point, assign load data, points load. The dead load, gravity minus Z, 750 kN. Size of loads for punching shear, so the dimension of column is 7, is on Y 750 and X 300. Okay, so click OK. Select again by get previous selection, or you can select. Okay, assign points load, live 600 kN, and the size of load for punching shear. So click OK and click display show undeformed shape. Now right click on these points and click loads. So the dead load is 750 kN and the load size for dimension for punching, and live 600 kN. So click OK. Now how calculate the area of single footing? The area is by this formula: Pn P surface 750 plus 600 over the bearing capacity. So I will open calculator, times 180, 7.5 the area, so 2.73. I will take 2.8. okay, a square footing 2.8. So open the safe again, click on define slab properties to define the footing, and click add a new property, slab 1. I will take, for example, the height of the footing 55%, so F 55 centimeter, slab material C30, type footing, and the thickness 550, and thick plate. For foundation we will take on thick plate to consider the shear, so thick plate OK, and define another. Click at copy, define stiff for column, so click st55, write stiff 55 and define as stiff. OK, the same thickness of footing, stiff 55, the material C30, the thickness 550 and thick plate, and click OK and OK. Now you can draw the slab area. I will choose a quick draw area around points. Firstly, I will draw the column by stiff 55. What is the dimension? The dimension is 0.3 and 0.75. Click on this point. OK. And F55, what is the dimension? 2.8. 2.8. Click on this node. OK. Click select object. Now I will assign the soil. So click define soil subgrade properties, soil 1, modify. What is the subgrade modulus? Equal 120 time the bearing capacity 180, and click OK. OK. Now click on the footing, assign support data, soil properties, soil 1. OK. You can click on 3D. So right click, F55, soil property, soil 1. You can change by clicking here. This is the geometry, this is the loads, no loads, and design T420. There are 3D, XY, and elevation. There is no elevation. Okay, so click now on display, show undeformed shape, and define the combinations. Define load combinations. Firstly, add a new combo, ultimate 1, the dead 1.4, and this strength ultimate. Okay, add copy of combo, ultimate 2, 1.2, 1.6, and click OK, and finally add copy of combo, service 1, 1, and service normal. Click OK and OK, and now you can click run analysis, or run analysis and design. I will click run analysis and design. The program asks to save the file, so click on a new folder and make sure to save this file in this folder. Okay, so isolated footing and click save. After analysis, the program shows the deformed shape displacement due to that load, the first load that you have defined, or the program defined. So now click on display, show deformed shape, load case that this is the deformed shape of foundation under that load. You can click live. So the maximum is minus 5.17 millimeter. That load. You can click live, apply. The maximum is 3.62. And you can choose load combinations, service, apply. The maximum displacement under service is minus 8.79 millimeter. Okay. Now we click close and we click display, show slab forces stresses. Under that load you can click on F11, F22, it's low, M11 to see the moment, click XY. This is the moment on this footing. M22, M max, apply, M minimum. You can choose a contour range in this box. And you can choose load combination, ultimate 1 to see the moment, and ultimate 2, apply. Apply and close. Click on display now and show reaction forces. Choose solid pressures and service. The solid pressure should be less than bearing capacity 180 megapascal. So service, apply. The maximum value is 190 kilonewton by meter square. So it's not verified. I should expand the footing. So I will click on unlock model, OK, and click on this footing, one area, 4 edge selected, edit areas, expand shrink areas. What is the offset value? For example, is 2.8, it will be 2.85, 2.85, so 50 millimeter, 5 centimeter. Okay, and click now, OK. So now draw dimension line, 2.9 and 2.9, 5% from left and 5% from down. So click run analysis and design, and you can click on this button, show reaction forces, solid pressure, apply. So 178.61 is less than 180 kilonewton meter square. So it's verified now. You can show the deformed shape now. Service is 8.26. And the moment change. To check the punching, click display, show punching shear design. The ratio is 0.5809. You can click on this node and right click to see all data. Load punching check, point label, and all calculations. Click done. Now How can I design this footing? Unlock model, OK, and click on Draw Design Strips. Strip A, column strip, 1.5, 1.5, 1.5, 1.5. The dimension of footing is 2.9, 2.9, 2.9. So the strip should be 1.45, 1.45, 5, 45. From center to center, midpoints. You can click on Set Display option to show the width of strip. So 1.45 left and up to down, 1.45. Okay. So now B, strip B, column strip, I will choose 1.45 from this point to this point. Okay. And now click Run Analysis and Design. Click Display, Show Slab Design. There are two methods, strip-based or finite element. I will choose firstly strip-based, impose minimum reinforcing from ACI code, layer A, and click on Show Number of Bar of Size. I will choose, for example, 14 top, 14 bottom. Layer A and show values at controlling station and diagram. And apply. I need 21 T14 bottom and 2 T14 top. So the maximum is the 21 T14. Layer B, 19 T14. Along this 2.9, not on meter. Along 2.9 meter, I need 19 T14. So I will choose T16, for example. So 15 T16 on Y, and layer A 16 T16. 16 T16 along 2.9 meter. You can click, for example, reinforcing or typical uniform reinforcing specified below, a mesh, for example, T16, and the spacing will be 200 millimeter, and tell me if I need an additional reinforcement. Click apply. Yes, I need 2 T16. So if I have a mesh T16 every 20 centimeter, I need 2 T16 an additional reinforcement. For example, T16 150, apply, I need nothing. Okay, and you can control by T12, for example, and T16 20. So I needed 3 T12. Okay, 3 T12. Layer B, I need nothing. Okay, I prefer to choose this method. So 16, for example, I need 15 T16, layer B, and layer A 16 T16. That's too easy. Click now on Design Bases. Choose Finite Element Based. direction 1 top rebar, direction 1 bottom rebar, direction 2 top rebar, and direction 2 bottom rebar. For example, I will choose direction 1 bottom rebar, typical uniform reinforcing specified below, and T16 every 20 centimeter. Click apply. I need an additional reinforcement in this area. You can calculate. The area is 184.63. You can calculate the number of bars. You can click direction 2 top rebar. I need in this area, and direction 2 bottom rebar. So this is the area of reinforcement, the additional area of reinforcement. You can calculate the number of bars, but I prefer in this case this method, strip based. Okay, so now click apply and close. So this is the design of single footing.